Hello and welcome to Dunia's Alchemy.
This video is part 2 of my GCSE Chemistry series on chemical analysis. It's for triple only students. The video breakdown is below. We're going to be looking at tests for anions and tests for cations. So let's begin. This is just a quick little breakdown. I've already mentioned this in the part 1 of the video. This is already done. If you do need to go have a look at these, go back into the part 1, which will be linked in the description below. But our focus now is tests for anions, which is our sulfates, carbonates and halides, and also test for cations. I've split that into 2 parts. I've called it flame for part A, and then your sodium hydroxide precipitate for part B. Anions are negative ions. There are 3 different types that you need to know about along with their test. The first one is the test for sulfates. Second is your carbonates, and thirdly are your halides, which are found in group 7. But please do remember these are anions, meaning these have a negative charge on them. So when you hear chloride, bromide, iodide, that means they have that 1- charge and they are not diatomic. So to begin, we're going to test for our sulfate. Make sure you know the charge of that ion. You add drops of dilute hydrochloric acid first. This is to remove any carbonate ions, as they're also going to give a precipitate and therefore a false positive, which basically means that you need to add that acid in order to remove any other ions that are also going to give us the result we're looking for. Then we're going to follow it up with drops of barium chloride solution. And the result is that if sulfate ions are present, a white precipitate of barium sulfate will be formed. Second one is our test for carbonates. Make sure you also know the charge and the formula for the carbonate ion. First, you're going to add drops of dilute acid. It can be any acid, but in our case, let's just say HCl. When you do that, you connect the test tube to a test tube of limewater. So this is actually testing you on something you've learned a lot earlier in your GCSE chemistry specification. And that is that when you add a carbonate to an acid, you release carbon dioxide. And therefore, if you remember as well, the test for carbon dioxide is that lime water turns cloudy. Last but not least is our test for halides. This time we're going to add dilute nitric acid into a dropping pipette. And then secondly, we're going to add drops of silver nitrate solution. Okay, I hope you've seen a pattern over here as well. The result is that depending on the halide that we're dealing with, you're going to get different color precipitates. So if there was chloride, you're going to get silver chloride precipitate, which is a white precipitate. If there's bromide, you'll get a cream precipitate. And if it's iodide, you get a yellow precipitate. So over here, I'm going to add all the tests for the anions on one slide so that you can copy it down if necessary. As you can see, the test for carbonates, test for sulfates, and test for halides, there are some patterns that you can notice. So when it comes to the test for the sulfate, if you notice, I've highlighted in green HCl and then barium chloride. So you kind of have 2 chloride containing compounds. And then also make sure you know the ionic equation in the middle. So Ba2+, your barium 2+, along with your sulfate 2- gives you barium sulfate solid. And then when it comes to your halide, you're adding these nitrate, this source of nitrate ions. So you start with nitric acid and then you add silver nitrate. So hopefully that should be a nice simple way to remember this. We are now going to be looking at the second part, which is testing for cations. We're going to start off with our flame test. So what you do is you place a clean platinum wire loop by dipping it into HCl and holding it into a blue flame from a Bunsen burner until it burns with no color. Then you dip the loop into the sample you want to test and you put it back into the flame and you record the color of the flame. So different metals are going to give you different colors. And you need to make sure that you know all the different types of colors that each one gives. I'm going to give you the results for each one over here. So make sure to note it down and learn them. The question is, why does this happen? When heated, electrons are excited to higher energy levels and then they fall back down to lower ones. These emit a light at a specific wavelength and that appears as different flame colors. So an example can be shown over here. When you expose it to heat, the electrons move to a higher energy level, and to do that they absorb energy. And then when the electron falls back down, light is emitted. Now, a second way of figuring out which metal you're dealing with is using flame emission spectroscopy. Feel free to pause the video and fill in the words using the word bank. So flame emission spectroscopy is an instrumental method and it's helpful as it is more accurate. It's very sensitive, which means it can detect the tiniest amount and concentration. And is very fast because tests can be automated. The method and explanation: a sample is placed in a flame. As the ions heat up, electrons become excited and then release light energy as they drop back into their original energy levels. As light energy passes through a spectroscope, this detects different wavelengths and produces a line spectrum. Each metal ion has its own unique line spectrum, and this can be compared. So I've taken this from the CGP Chemistry Revision Guide because it's a really good image and it shows clearly what we're talking about. So let's say over here, this is what we mean firstly by a line spectrum, right? This one over here at the top. Flame emission spectroscopy. So for example, let's say we have a solution containing different ions, and this is the spectrum that you could be given in an exam. The combination of spectra for ion X and Y, both of them line up to give you the solution for different ions. So these last two at the bottom are proof that the first one contains both of them. We're now going to have a look at sodium hydroxide precipitate. So many metal hydroxides are insoluble and they give a precipitate. These give characteristic colours. You simply add a few drops of sodium hydroxide to a solution of your mystery compound. The table below over here, I've shown you all the different metal ions along with the colour of the precipitate they make and the formula of that precipitate. Firstly, it says copy the table over here, so do make sure you make a note of it. But secondly, it says what do you notice regarding the metals that give colour? So if you look at the metals that actually give some colour, it's copper, iron 2+ and iron 3+. The other ones do not. So what makes these different from the other ones? The answer is that they are transition metals, and one of the properties of transition metals are that they give coloured compounds. Another thing to note is also that with transition metals, because they can have different charges or different oxidation states, so 2+ copper you're talking about, they will show it to you in Roman numerals, and also depending on the charge on the ion, that will also be shown in Roman numerals. So if it's iron 2+, you're going to see the 2 there. If it's a 3+, you're going to see the 3. Another thing to make note of is that because your hydroxide is a OH-, it's only a 1- charge, depending on the charge of the metal, that's how many hydroxide ions you'll need. So if it's calcium 2+, you need 2 hydroxides, and that will be shown by the little 2 at the end of the brackets. But if it's an iron 3+ or aluminium 3+, then the way that is shown is with a little 3 at the end, because the metal ion was a 3+ charge, and therefore you need 3 negatives in order to cancel that out. We've now done both part 1 and part 2. That's our video complete. Testing for anions and cations is done. Make sure you do the 3, 2, 1, share it with 3 others, give it 2 clicks, like and subscribe, and 1 comment. I'll see you in the next one.